tomorrow. But I didn't want to inundate you with too much information today. So proteins have many unique roles within our bodies. Those roles can be roughly broken into two categories, one being structures and two being tools. So those structural proteins, that's what we see of each other. We see a lot of our own proteins. That's what our body is made out of. And tools are those things that are dealing with processes. The book makes a point to list what they think are the most important of the proteins and their functions on page 256. Since it is pointed out so specifically, I recommend you memorize them. And when we have our time to read today, that would be a good time to maybe make some flashcards. Okay, so page 256 for that. So protein structure, just the beginning of it. We're going to get into all of the different ways that it goes into 3D later. But we know that proteins are polymers. It's a good place for us to start. And what are polymers made out of? Monomers, absolutely. Well, specifically when we're dealing with proteins, we call these monomers amino acids. So the monomers in this polymer of proteins are called amino acids. Amino acids. We just finished up a bunch of organic chemistry. If you heard amine, what are you thinking of? NH2. Beautiful. And acids. Where did we deal with acids? Carboxylic acids. Good. What were the carboxylic acids? Their formulas. COOH. Very nice. COOH. So we have those two things in all of our amino acids. So amino acids contain an amine group and a carboxylic group, and both of those groups are bonded to one carbon. Really going back here, how many bonds does each carbon have to have? 4, absolutely. So that means that there's going to be some other stuff attached to it as well. Generally, we'll have a hydrogen on it. Here's my amino group or my amine group, my carboxylic acid group, my COOH. And then I'll have some side chain there as well. So all amino acids have this part, this middle part here. All amino acids have that middle part. So it's this R part that makes them individuals. Still see a few pens going. I'm going to wait on this image just a little bit longer. Okay, so the R group is what specifies which amino acid it is. And there are around 20 unique amino acids found in natural proteins. Each of those 20 amino acids are given a 3-letter abbreviation, rather than those big, long organic names that we spent so much time learning how to do, those big, long IUPAC names. This is trying to make our life a little bit easier when we're dealing with proteins, because proteins are made out of so many different amino acids. It's chains and chains of amino acids. So it makes our life much easier if we can just represent them with 3-letter abbreviations. And luckily for us, these are all given in our data booklet. So they're not things that we have to memorize. Not only does the R group specify which amino acid it is that we have, but it's also predicting the chemical nature that we have. And you've got a big open spot on the back of your page to make this chart. So our amino acids can basically be broken down into 4 main groups that we're going to deal with. We have nonpolar amino acids. We have polar but uncharged amino acids. We have basic and positively charged amino acids, and that's when they're in a substance that has a pH range of 6 to 8. And then we have amino acids that are acidic with a negative charge when we put them in something that's a pH of 6 to 8. And I'll give you a chance to write before I talk any more about the chart. Mm-hmm. Yeah. Now we all write at very different rates. I'm going to start talking through this a bit. So if my amino acid is nonpolar overall, it's because it has a hydrocarbon in its R group. So just hydrogens and carbons, nothing else fancy attached to it. And this is just an example of it here. I have my amine group, I have my carboxylic acid, and then really simple basic one, I've got a methyl group here. It's probably that is the most basic I can get.
Are these all just example structures?
Yep, all just example structures. If it's polar but uncharged, I have one of these types of functional groups as my R group. I have an alcohol, which we know is an OH, a sulfhydryl, that's a sulfur and a hydrogen, and an amide has both an oxygen and a nitrogen. thinking back to organic chem. So this example, I've got my amine group here, my carboxylic acid group here, and then I have a CH2OH. So I have an alcohol in this one. If it is basic with a positive charge, I'm going to most likely have an amine group, or an amino group on it, in addition to the one that's already there. So I have my carbon with my amine and my carboxylic acid, and then attached to that, this one's got a nice long chain. It might not be that long. CH2, 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 NH2. And this again is just one example of it. So there's my amine group at the very end, not already part of my amino acid. And then acidic with a negative charge, the R group is going to contain a carboxylic acid. So I have my amine group, my carboxylic acid group, and then I have a CH2COOH, so another carboxylic acid. So I have an excess of acid on that one. So amines are basic, carboxylic acids are acidic. They generally cancel each other out for just that part of it, and then if we add more carboxylic acids or more amines, that's going to make it either more acidic or more basic.